Alright, this is Algebra 2, Unit 8, Day 11 review for test. You should do this before you watch this video. You also have the answer key to check your answers with, so if you have any questions, you can fast forward to the problems that you want to watch the solution to. I am going to make 2 videos for this review sheet since it is so long. So this is part 1. We'll go to number 9 or number 10. Alright, fill in the blank. So they give us this function, which has a degree of 5 and a negative leading coefficient. Now I know if I have an odd degree, my tails do not match. One goes up and one goes down. Now if I have a positive leading coefficient, they go up and to the right, which is both positive directions, or down and to the left. 2 negatives make a positive. If my leading coefficient is negative, it will go down to the right, up to the left, which is what we have here. So it says as x goes to positive infinity, that means as x goes to the right, what happens to your y value? It is going down. Remember, f of x is y. So it goes to negative infinity. This function can have at most 5 real roots. Okay, it might not have 5 real roots, but it can't go over 5. That will always match the degree. And it can have at most 4 turning points, which is always 1 less than a degree. Number 2, we have an even degree, so that means my tails will match. We have a positive leading coefficient, that means both tails are going to go up. So as x goes to negative infinity, which is toward the left, the y values are going to go to positive infinity. It can have at most 8 real roots and 7 turning points. Draw a rough sketch of a 6-degree polynomial. That means my ends are going to match. That has only four real roots and a positive leading coefficient. So tails match, positive leading coefficient means they both go up, but I'm only allowed to have 4 real roots. You can draw them anywhere on the x-axis you want. If I count this root to be my last one, it goes up. And if I count this root to be my first one, that goes up. Turn, turn. Now I'm going to put a little extra turn in here for my imaginary roots. And there, I have only hit the axis 4 times. I did not look at the answer key prior to making this, so this graph might be a little different than the one in the answer key. But keep in mind, you could stick those imaginary roots anywhere you want, so there are many, many graphs you could draw for this problem. Alright, draw a rough sketch of a 3rd-degree polynomial with a double real root and negative leading coefficient. Well, 3rd-degree polynomial means that it's only going to have 3 roots total. If I have a double real root, that counts for 2 roots already. That means I'm only allowed to have 1 more root. Imaginary roots come in pairs. So the other root is also going to be real. Now the last question said only 4 real roots. This one just says I need a double real root and hasn't specified anything about any other roots, what you're allowed or not allowed to have. Since imaginaries come in pairs, it can't be imaginary, or you'd have 4 roots, so the other root is going to be real. And a negative leading coefficient means we're going down to the right, up to the left. Alright, so I need a double root, and if I count that as my last one, then that's coming down, and I have to have a turning point there. So the only way that I'm going to have my left side go up is I have to turn again, which means I will cross the x-axis again, which will give me another real root. Find all the roots of the following polynomials. Classify each root either from a double root, real, rational, irrational, imaginary. Alright, so in order to find the roots, we have to do a lot of factoring. GCF is the first kind of factoring, so I'll take out a 2x squared. That will give me an x to the 4th minus 16, which happens to be difference of squares, so we will factor that as x squared minus 4, x squared plus 4. And I see difference of squares again, so x minus 2, x plus 2. Remember, this x plus 4 is not difference of squares, it is the sum of squares, which means you can't factor it. Now that you have all the factoring done that you can, you set everything equal to 0. So 2x squared equals 0, x minus 2 equals 0, x plus 2 equals 0, and x squared plus 4 equals 0. So divide by 2, x squared equals 0. Take the square root. Now remember, when you take the square root of something, when the square root wasn't there before, you get two answers. So we get positive and negative 0, which of course is the same number, but I leave the positive and negative on there to remind me that this is a double root. Alright, this one's going to be x equals 2, this one's going to be x equals negative 2. Subtract 4 from both sides, and x squared equals negative 4. Square root both sides. Again, automatically, I'm going to get a positive and a negative answer. Square root of 4 is 2, and because it's negative, I get 2i. So the first one is double, real, and rational. X equals 2 is real and rational. X equals negative 2 is real and rational. And the i's are imaginaries. Alright, number 6. Look for GCF first. 2x will do it. So that's going to give us 2x cubed minus 5x squared minus 6x plus 15, which has 4 terms, so I'm going to jump to grouping. I'm going to leave this guy for a little while so he doesn't get mixed up. First group has a GCF of x squared. When I pull it out, I get 2x minus 5. This one has a GCF of negative 3. When I pull it out, I get 2x minus 5. So my factors are 2x, 2x minus 5, and x squared minus 3. And I'm setting them equal to 0 to find the roots. X squared minus 3 is not difference of squares, so we're done factoring. Set them all equal to 0. So x equals 0, which is real and rational, but I only got 1 0 this time. X equals 5 halves, which is real and rational. And this is x squared equals 3. Take the square root of both sides. You automatically get a positive and a negative. Square root of 3 can't be simplified. It is real because there's no i's, but this one is irrational. Okay, 2 separate ones. One's positive, one's negative, so it's not a double. Alright, number 7. GCF looks like a 2. That's going to give us 4x to the 8th plus 9x squared minus 9 equals 0. Yeah. Nope, sorry, 9x to the 4th, my bad. Okay, this is quadratic-like because the exponent on the first term is double the exponent in the middle. And since there is a leading coefficient of 4, we have to do factor by grouping. So I'm going to ignore this 2 for a while. He'll join us later. 4 times 9 is negative 36. So we get negative 1, 36, negative 2 and 18, negative 3 and 12, and that's the one we want. So 4x to the 8th minus 3x to the 4th, because that one has a 4, plus 12x to the 4th minus 9. Groups of 2. GCF is x to the 4th. I get 4x squared, no, 4x to the 4th minus 3. And GCF of this one is a 3, and I get 4x to the 4th minus 3. So my factors are 4x to the 4th minus 3, and x to the 4th plus 3. And now I'm going to bring down my original 2. 4x to the 4th minus 3 is not difference of squares, so I can't do anything with it. X to the 4th plus 3 is not difference of squares, not even a difference, so I can't do anything with it. Set each factor equal to 0. 2 equals 0 has no variables. 2 never equals 0. It's called extraneous. We'll cross it off. 4x to the 4th minus 3 equals 0. X to the 4th plus 3 equals 0. So 4x to the 4th is equal to positive 3. Divide by 4, we get 3/4. So x to the 4th equals 3/4. To get rid of that 4th, we have to take the 4th root. And because that root is even, I do get a positive and negative answer. And it is real, but irrational. We can't get rid of that radical. All right, this one. X to the 4th equals negative 3. I need to take a 4th root. There is no number that I can multiply to itself 4 times and get a negative answer. Therefore, I am going to get a positive and negative because it's going to be imaginary, 4th root of 3. So you get 2 imaginary roots. For those of you who are worried that you're going to see one this difficult on the test or on the Regents, unlikely. Good job if you got that one right. All right, sketch a graph of this one. Let's factor it so we can find what our roots are so we can get a decent one. When they give you a grid, they really want you to sketch the roots with it. So I'm going to pull out, I'm going to pull out a negative x cubed, just because that'll make my leading coefficient positive. All right, so that'll give me a negative 2x squared, and that'll give me a positive 1. So by pulling out that negative GCF, it made my leading coefficient positive, which is a good thing because this is now quadratic-like, and I can factor it. So I have an x squared and an x squared. 2 numbers that multiply to a positive 1, add to a negative 2, are negative 1 and negative 1. Bring down this guy, which happens to be difference of squares. So negative x, x plus 1, x minus 1, x plus 1, x minus 1. So negative x equals 0. So 0 is a root. X plus 1 equals 0. X minus 1 equals 0. And we would get that twice. So x equals negative 1 is a double root. And x equals positive 1 is a double root because I will get those same 2 answers from these 2 guys. All right, so now we know where the roots are. So we have a double root at 0, 1, and negative 1. Holy small graph. All right, we are going to blow that up. I'm going to go put that in my calculator to see what the rest of it looks like. So again, when they say sketch the graph and they give you graph paper, they really would like you to plot the roots. And then from there, we're going to estimate. I have a new calculator sitting in my hand that works different than the 83. So excuse me for taking a little while to type this. All right, so I'm going to hit graph. Yeah, it's not really showing me a whole lot. Okay, so because it's an odd degree, my tails do not match, and because it's negative, it goes down to the right and up to the left. So as you can see on the graph, it goes this way and this way. So you know it's going to go squiggly in there somehow, but you aren't going to see it on your table. So I am actually going to go zoom on my calculator and hit zoom in. It barely goes up. All right, I'm going to try zoom in one more time. Okay, so that doesn't help me find where my maxes and mins are. So I apologize, this probably was not the best example to put on our review sheet. Domain, negative infinity to positive infinity, we can answer that easy. Range, low to high, negative infinity, positive infinity. This relative max and relative min, okay, we can't even make it show up on our calculator, so that means it's going to be really, really small. But I'm just going to label it on my graph. This is the relative max, and this is the relative min. And they would give you an equation where you could actually see it on your graph or see it in your table so that you could answer this question. And what you would do is you'd put the coordinates of the point of the relative max and the relative min. All right, x-intercepts, those are the points where it crosses the x-axis. Oh, you know what? I drew that wrong too. Negative 1, 0, 0, 0, and 1, 0. Okay, I just realized I drew that graph wrong. Let me try again. The reason why I drew the graph wrong is I forgot about the double roots. Okay, we have double roots at 1 and negative 1. So we said the end behavior, this goes down, but you got to have a turning point here. Then it can go up, and then it's going to have a turning, stop doing that, and it's going to have a turning point here, and that's also a turning point. So my apologies for the graph not being very nice. I don't know, maybe that's what I had. There's your relative max, here's your relative min. Okay. Y-intercept, we're not really sure. Y-intercept is where the x value is 0. Well, yeah, that's a 0, 0. Over what interval is the graph decreasing? It is decreasing from the left side until you get to here. And then it's also decreasing between these two guys. So it's decreasing from negative infinity to negative 1. Remember, you always report the x values. It's also decreasing from, we're going to take a guess that that is a 0.5. Sorry, negative 0.5 to a 0.5. Okay, we're estimating. Increasing is from negative 1 to negative 0.5. And then 0.5 to 1. And we have another decreaser over here from 1 to infinity. So we have 3 intervals where it decreases and 2 where it increases. All right, for what intervals of the domain is f of x greater than 0? So they're talking about y values greater than 0. That's talking about positive y's. So if I draw the x-axis in blue, anything above the blue line is going to have a positive y value. Well, since we have the arrow over here, that's going to start at negative infinity and go until we hit the x-axis, which is at negative 1. Open parenthesis, because we cannot count the negative 1 because that has a value of 0, not bigger than 0. And then that little dip up above. We said that was a turning point, so from negative 1 to 0, that little hump right here is also above 0. All right, less than 0, we have to split it up because we hit the 0. So this little trough right here, which goes from 0 to 1, again, round parentheses because we can't count the endpoints, they do hit the 0. And then from 1 to positive infinity, the x value, those are y values less than 0. All right, average rate of change over the interval 1, 3. Well, the x value 1 has a y value of 0. If you look at your table, the x value of 3 has a y value of negative 1,728. Goes down really fast. We're going to do rise over run. So negative 1,728 minus 0 over 3 minus 1. So that's negative 1728 divided by 2. So we get negative 864 over 1. That's a really big, fast change. I apologize for this function. I will make a note that we should change that one because can't see it very well. Alright, number 9. We'll do 9 and 10, and then we'll stop this video and start the next one. Write the function with the following roots. Okay, so remember that any imaginary or rational functions are conjugate pairs. So, of course, the Regents is only going to list one to make sure it can test you on whether you remember that there's actually 2 of them. There's a positive and negative 2i here. So this has 3 roots, a negative 1, positive and negative 2i. That means we should have a function that has an x cubed. All right, so we're working backwards. Had we solved the problem, we would have gotten x equals negative 1 and x equals positive or negative 2i at the very end. So now we got to work backwards. Prior to this, we would have had an equal 0 here. So we set that one equal to 0, and now this one's ready to go. We have never seen functions that have i's in them, so we need to get rid of the I. The I term is isolated, which means now we can get rid of it by squaring both sides. So that gives me an x squared. And over here, 2i times 2i is 4i squared. I squared is a negative 1, which turns that to a negative 4. Now I can set it equal to 0 by adding the 4. So I get x squared plus 4 equals 0. And now that one's ready to go. It says write a function. So the x plus 1 would have been in parentheses. The x squared plus 4 would have been in parentheses. And it would have been equal to 0 or f of x. It did not say standard form. Therefore, I do not have to multiply those out. And we're done. All right. Write a function with the following roots. So they listed these separately. We can stick them together. It makes life easier. But this one, they only put one of them. They did not put its conjugate pair, so we're going to add the negative 1 in here. So we have a 4th degree equation coming up. So we would have had x equals positive or negative 2i at the end, or we would have had x equals 2 plus or minus 2i at the end. All right, both of these have i's. We have to get rid of the i's before we can set it equal to 0. So we are going to square both sides on the first one because the I term is alone. We just did this in the problem before, so we know that turns out to be a negative 4. Add the 4, and this piece is ready to go. This one on the right, a little more complicated. I don't want to square both sides until my I term's alone, so I'm going to subtract the 2. That gives me x minus 2 equals positive and negative 2i. At which point, since my 2i is isolated, I can square both sides. I know the right side comes out to be a negative 4, because that's 3 times in a row we've just done it. The left side I need to double distribute. X squared minus 2x minus 2x plus 4 equals negative 4. So x squared minus 4x plus 4 is equal to negative 4 when I combine terms. Now add the 4 to the left. We get x squared minus 4x plus 8 equals 0. Now that that's equal to 0, we're ready to write our function. X squared plus 4 would have been in one set of parentheses. X squared minus 4x plus 8 would have been in the other set of parentheses, and that would either be equal to 0 or f of x. It did not say standard form. We are not going to multiply this out. Alright, so that's the end of the first video. I will put the rest of the solutions in video number 2.